Hello and welcome. Today, we're cracking open the ultimate builder's toolkit for anyone who works with data. And that toolkit is Python. We're going to demystify the essential tools that help you turn messy, raw information into clean, actionable insights. So let's get started and open up the toolbox.
You know that feeling, right? Data is coming at us from everywhere, and without the right tools, it can feel totally overwhelming. But just like a builder needs a hammer and a level, anyone working with data needs a way to organize, manage, and shape that raw material. And that's exactly what we're doing today, building out your foundational toolkit. So first things first, we need a place to actually put our data. Before we can analyze anything, we have to store it. Python gives us some fantastic built-in containers, and each one is designed for a specific kind of job. Think of these as the different boxes and bins you'd have in your workshop.
Okay, so here's the deal. We've got 4 basic options on the table: lists, tuples, dictionaries, and sets. The whole game is just knowing which one to grab for the job at hand. Are you going to need to change things later? Does the order of items matter? Can you have duplicates? The answers to these questions are going to point you to the perfect container every single time. Now, the list is your all-purpose go-to container. It's ordered, which just means items stay in the exact sequence you put them in. And it's changeable or mutable, which is why the shopping list analogy is so perfect. You can add milk, you can cross off bread, you can move eggs to the top. It's super flexible, and honestly, for a lot of tasks, it's all you're going to need. But then you have the tuple. It's also ordered, but here's the crucial difference. It is unchangeable, or immutable. Once you create a tuple, its contents are literally set in stone. And this is a lifesaver when you have data you need to protect from being changed by accident, like, say, configuration settings for an app or the RGB values for a color that should never, ever change. And this just brilliantly shows the power of a dictionary. Instead of finding items by their position in a line, you find them using a unique label or a key. It is incredibly efficient. If you want to find someone's age, you don't search through a whole list. You just ask for the age key, and boom, you get a value back instantly. It's all about that quick, labeled retrieval. So we've got our data stored neatly in its containers. Great, but that's just step 1, right? Now we need tools that can actually do things with that data. Tools that can make decisions, perform repetitive tasks, and really bring our data to life. This is the fundamental logic path for pretty much any program. Imagine your code comes to a fork in the road. It asks a question with an if statement. Is it true? If yeah, it runs that code and moves on. If not, it checks the next elif, which just means else if. And if none of those conditions are true, it falls back to the else block. It's a really simple but powerful way to control the flow of your code. Okay, loops are the assembly lines of our toolkit. The for loop is perfect when you have a collection, like a list, and you want to do the exact same thing to every single item in it. The while loop, though, that's different. It just keeps on running as long as a certain condition is true. You use that one when you don't know exactly how many times you'll need to repeat something. You know, as our projects get more complex, we really don't want to be writing the same exact lines of code over and over again. It's just inefficient. So the next level up is learning how to package our instructions into our own custom reusable tools. And that right there is where functions come in. A function is basically a named block of code you can call whenever you need it. You can hand it some data, it does its specific job, and it can even give you a result back. This makes your code so much cleaner, more organized, and way easier to manage. The main idea is simple. Write it once, use it everywhere. So think of a function like a custom machine you've built. The parameters are kind of like the input slots on that machine, and the arguments are the actual materials you feed into it for a specific job. And what's really cool is that Python is super flexible here, letting you build tools that can handle a variable number of inputs, which makes them even more powerful and reusable. The tools we've seen so far, they're essential, like a good hammer or a screwdriver. But when you're ready to build something really big, when you're dealing with massive data sets, well, you need to break out the heavy machinery. And that brings us to the world of pandas. Let me be really clear about this. If you are doing any serious data science in Python, Pandas is not optional. It is the absolute cornerstone, the workbench, where all the real analysis happens. I mean, this quote really nails it. Pandas takes all the concepts we've just learned and basically turbocharges them. It's built for speed, it's built for efficiency, and it simplifies really complex stuff like filtering and transforming data into these single, elegant commands. So what's Pandas actually made of?
Well, the smallest unit is the series, and all it is really is a single column of data, just like one column in a spreadsheet. But the key thing is that it has an index, or a set of labels, which makes working with the data so much easier.
And when you put a bunch of those series together, what do you get? You get a data frame. And this is the star of the show. This is the main thing you'll be using in Pandas. It's a full table, just like an entire spreadsheet, with labeled rows and columns. This is your digital workbench.
All right, we have the Power Tool plugged in. Now, how do we actually use it to find the stories that are hiding inside our data? Let's look at a couple of core operations that you will use constantly.
Okay, now this is super important because it's something that trips up pretty much everyone when they're starting out. How do you grab a specific piece of data? You've got two main tools. Lock uses the actual row and column labels. iLock, on the other hand, uses the numerical position or the index. Just remember, L for label, I for integer location. Getting that down will save you a ton of headaches.
So check this out. Here's a simple data frame. We've got a key column with repeating values, A, B, and C, and a data column with some numbers. It's clean, sure, but it's not very insightful. We want to understand what's actually happening for each of those keys. And then, bam, look at this. With one simple command, group by key.sum, we've collapsed all that raw data into a meaningful summary. We can instantly see the total sum for A, for B, and for C. This is the core of data analysis, grouping and summarizing to turn noise into a clear signal.
All of these tools we've been talking about, they all come together in a process called Exploratory Data Analysis, or EDA. And really, you can just think of it as a detective's workflow. As you can see here, you start by loading the evidence. Then you dust for fingerprints by checking for things like missing data and outliers. It's only after you've cleaned up the scene and understood the layout that you can really start piecing the story together.
So, we've filled your toolkit, you've got containers to hold your materials, logic and loops to shape them, and the Pandas power tool to build really complex structures. We've laid out the foundation. Now, the real question is, what story will you uncover? What insights will you build? The tools are in your hands.